So where are we?
We're in my office. I'm Paul Vick. I'm the Visual Basic technical lead for the language and compiler.
And?
I'm Erik Meijer. I'm helping Paul designing the next version of VB.
And where do you work? What group?
I'm from SQL Server.
Okay. A developer? Architect?
I'm an architect, so yes. But yeah, I'm just a language geek, so that's more important. My title doesn't really matter.
And our topic in depth today?
Is dynamic, the dynamic aspects of programming in Visual Basic, both in terms of the current release, the would-be 2005 release, and features we're considering for beyond would-be.
Got it.
Not attached to any release yet.
So what does dynamic programming mean in context of Visual Basic and other languages?
That's a really good question. Well, I mean, I think if you ask 10 people, they'll give you 20 different answers for what dynamic programming is exactly. It's a little bit different for everybody. But at least my answer for dynamic programming is programs that can react and change based on runtime state, so that can execute dynamically based on the data that's in your running application rather than the data that you knew about at the time that you were compiling your program.
Yeah, so in a kind of statically typed language, whenever you call a method on an object or you access a member, the compiler has to know the type of that object. Otherwise, it doesn't, it cannot decide what member to call. In a dynamically typed language, you don't have to know that at compile time, but the runtime will figure that out at runtime. And we will see, when we do the demos, how that works.
So it sounds like dynamic programming aspects are the language features and the compiler combined.
Yes, the compiler kind of needs to know about, the fact that you can do this late binding. And this is like, I keep saying this to everybody, VB I think is unique in the fact that it allows both statically typed, calls and late bound calls. So not many languages allow that. So it's like, if you look like C# or C++, it's only statically typed. If you look at the typical scripting language like ECMAScript or JavaScript or Python, it's only late bound. And VB allows you to kind of pick and choose whatever is most convenient.
So the dynamic aspects of VB script and JavaScript are more in the language and not in any kind of compilation usually, right? It's like the runtime and the syntax combined. It's not in any kind of compiler since it's being interpreted.
Well, the compiler there has much less notion of static types. It defers everything until runtime, yes, because it interprets everything. Whereas VB allows you to kind of, if you know the type statically, you can use that and you get IntelliSense and more efficiency. But if you don't know the type statically, then you can defer this to runtime.
Are there ways to use Visual Basic to be a dynamic programming environment versus not use it in that way?
What do you mean by...
Like settings, or, I assume there's some benefits to the dynamic programming aspects, but yet it's sometimes methodology and not automatically there.
Or you mean option explicit, or?
And beyond that, just what are some examples of what makes VB dynamic, in a sense, versus another language, like even C++? Is VB more dynamic than C++? And if so, why, and what are examples? So people get a concrete idea of what it means to be dynamic.
Well, I think the example that Erik was using was probably a really good one in terms of late binding, because a lot of languages, especially a lot of the C languages, don't have any concept of late binding. And late binding is really useful mostly when you're dealing with objects or with information that's coming in that you don't know the structure of at the time you're actually building the application. So like part of the reason why Visual Basic has late binding is because of sort of the COM history of the language, where you were working with objects that maybe had no compile time type information, and you just sort of, the shape of the object was determined entirely at runtime. And so late binding allows you to work with these kinds of objects where the members can be different every time you run, but as long as you know as long as the members you know are going to be there show up, then it'll work. So that you can make very little assumptions about what your objects are going to look at runtime, and as long as they conform to your minimal expectations, everything works. Whereas in a more statically typed language, things have to look exactly, on the CLR, things often have to look exactly the way that they were when you compile the program, or else everything breaks. Your program just won't run.
So why don't we just kind of go off and do a demo
Okay,
to show this?
sure.
Sounds too abstract.
Yeah,
Let's show some real code.
Sounds good.
Yep. So why don't we define two classes that have like a name field, right? Like DVD and person or something
Okay.
like that. Then.
Right. So, string, so we'll just use fields for right
Yes.
now. Right.
So now you see that these two types, they both have a field name, but for the rest, there's no type connection between them. They both inherit from object, but there's no kind of common structure.
So let's say I wanted to
Yeah.
print the name of one of these objects. So one possibility is that I would then have to, declare the name, the type of thing that I want to, object as, a DVD. All right, now that I have a DVD, now that I said it's a DVD, I can console.write line the object.name, because I know for sure that DVD has name. Or I could similarly declare this as being a person, and that will also compile. But there's no way but in other languages, if I were just to say, well, it could be either a person or a DVD. Now you notice that Visual Basic doesn't give you an error, because what it'll do is now it says, well, this is just a general object, so I'm going to defer until runtime, figuring out how I'm going to actually access the name property. But if you, let's say instead of here we had option strict on, which turns off late binding. So now I'm not allowed to do late binding. So now I'm more like I'm working in something like C#.
So does turning that on make VB more dynamic or less dynamic?
Less dynamic. So option strict on means that C#, or it's now just like C# or C++, completely statically typed.
Okay.
And option strict off allows you to do this late
Right.
binding, so it makes it more dynamic.
So with an option strict on, if I really didn't know what kind of object I was going to get for this method, what I'd have to do is I'd have to use some kind of reflection APIs here. Let's see, I'm not even, to be honest.
So you say object dot get type.
Yeah, so then is type equals.
No, you don't even have to do that.
Well, I'm just using it to
Okay.
figure, because I can never remember how this even works. It's so complex. Okay, maybe you're. Do you want to?
Well, so if you just say, object dot get type dot, then IntelliSense will help you a little bit. So.
Okay.
Dot find member, get field. If you go
Let's
down.
see. Oh, maybe I'm. Here we go. There we go.
Yes.
I was
Get
restricting. There we
get
go.
field. Is there a get
Get
field?
field.
Yep.
All right.
Okay. And then you get field name.
Name
Yep.
and binding attribute.
No, you don't need to do that. Just
Okay. No, but there's no overload, so
yep. Just get that name.
get field.
Yep. Dot. Oh, you don't need to get the binding flags. Just to do the get name.
All right.
Just get name. And now you can remove that. You see how, and then you say dot invoke. Is there
No, get value.
get value? Yep. And then you have to pass object again.
So how do you summarize what you're trying to show here?
Okay. So here is what we're trying to do: is if you don't have late binding,
You're watching two people who know the CLR very well, trying to figure out how to late bind
Yes.
using manually.
With options strict on.
Without
well, or if you have a language that doesn't support
Right.
late binding,
Not-
this is you have to go through all these hoops to call the name field of that object. Okay. So let's see if this actually works.
So let's see. All right. So DMD is new DVD. D.name equals gladiator. Print name D.
Yep.
All right. Oop, I should have. It's gonna just go. All right. Let me put a read line in there to prove that we. It's all about read line. We actually know what we're doing here.
Yep.
All right.
Yep, there you
there's
see.
Gladiator. So, but what's interesting, of course, is that this works great right now because I'm telling it to get a field, but let's say actually I wanted to change this to a property.
Yeah.
Property. some string and return name equals value.
Yep.
Now what's going to happen is I'm going to get an exception because this is now not a property and not a field as I had actually told it was going to be. So the get field failed. Now, if we go back to our lovely option strict off world.
And this is unique to Visual Basic, set option strict off?
Yes,
Yeah.
yes. So again, as I said in the beginning, Visual Basic is kind of the only language that allows you to kind of, toggle whether you want to have late binding on or off in the same, in the same language. Usually you're forced by the language to be either completely statically typed or completely untyped.
Now, is the compiler doing things at design time, or when you hit F5 a build project, or both?
Well, what it's doing is here. So I've now changed it to object, and I've gone back to late binding. And so if we run this, it works. Now, actually, for example, here, let me show you actually.
Do it with person where there's a field, right?
T as new person.
Yep.
P.name equals Paul. Print name D. Oops. Now if you look, so now we're calling it with an object, one of which has a name property, one of which has a name field, but it really doesn't matter because the runtime late binder will actually figure it out. Now the interesting thing about this is that the way that it works essentially is that we built a piece of the Visual Basic compiler into the runtime. So we took our compiler code, we translated it into Visual Basic. Actually, we used our own language for a runtime. And when you type object.name at runtime, what will happen is it will invoke the same code that would have run at compile time to figure out what name is and what it means.
Now that would be similar to a scripting language, right, where it has to know about the language at runtime and
Sure,
not just
yes.
compiling into some.
Yeah,
Exactly.
and here's something interesting. If you look at the code there, you see when we do d.name equals gladiator and p.name equals Paul, that is actually statically typed because at that point the compiler knows that D is a DVD, so d.name is actually a property setter, whereas p.name is actually a field setter.
Now, if you
Okay.
set option strict on here, I assume it wouldn't run.
No, that would run, but what Paul was saying, that what happens at runtime, when I now say in that code their print name, when I say object.name, there is the same logic that checks, well, is this a property? I have to do property access. If it's a field, I do field access. So it's like a lot of the logic that's in the compiler is kind of, done now at runtime, because at runtime we know the true type of the object. Here we only know at compile time that it's object, but at runtime we know whether it's a DVD or a person. So the runtime helpers can inspect the type and do the right thing.
So would the code to do the same thing here in C# or C++ look a little different?
Look much. That's
Yeah,
what we showed
right.
here with this reflection, this
Okay.
horrible code that we
Well-
were trying to do.
And actually what we showed was, we just showed the simplest case of just getting a particular field. Like, we did a lot of work in Whidbey in 2005, because what our late binder does is it doesn't just handle field versus property versus method, it also handles overload resolution for methods. We actually did that previous to Whidbey. But then we also handle, we handle generics now in 2005, we handle unsigned types, and also, we also actually, let me show you here actually, and actually talked about this before, but there's another aspect of dynamic programming in Visual Basic, which is that it doesn't just apply to calling members. The late binder doesn't just work on accessing a property or calling a method, it also applies to operators as well. So like, let me show you an example here. So if I wanted to, let me get rid of some of this stuff here because it's getting a little cluttered. Well, actually I'll leave it in because we might need it, but let's say I wanted to write a function that added two things together, and I don't really care what it is that I'm adding as long as it is addable. Now this is actually particularly starting to be a problem, with generics, for example, although there are some quirks with that and late binding, so maybe. But So what I can do if we go back to the screen is I can just say O1 is object. In fact, I don't even really need to specify the types here. So now what I can say is return O1 plus O2. Now I didn't state the types. Now if I don't state the types, that's as good as saying as object. I'll just stick it in for clarity's sake, but as object here, and then of course I didn't specify it as object. Now what this will do then is at runtime, it'll look at the two objects that we're trying to add together, and it'll figure out, are these things addable or not? If you added two, if you tried to add two DVD objects, it'll fail because there's no add operation on those. But for example, here, if I go down here, let's just get rid of this code. But if I said demo1 equals 10, demo2 equals 20, console.writeLine add O1, O2, it'll figure out that the two, and hopefully you can see that in the 30 there. But the really interesting thing is this is fully dynamic. So let's say, I just added two integers together.
So why don't you define an add on the DVD class?
Well, we'll get to that in
Yes.
just a second.
Okay.
I wanted to show, if I wanted to add, let's say this is a double value. So this is an integer and a double. Or actually, let's make it a decimal, even better, 20.5 decimal. So what will happen at runtime is the compiler will, the runtime part of the compiler will figure out that it's a decimal and it's an integer, and it'll figure out how to add those two things together and what the result type should be. So you can actually do all kinds of math based on the dynamic type of the values you have if you don't know them at compile time.
And again, there's features and implementation here that are unique because of
Yeah,
the
right.
compiler
This is,
feature.
right, exactly. To do something like this, you would essentially have to just you'd have to build the same component that Visual Basic does, which is, you'd have to take a look at the two types and figure out how they could be added together and all this sort of thing.
So, and plus you would have to know that, when you write plus in VB or C#, what actually gets called under the covers is not plus. It's, what is it, operator, whatever. So there's some kind of name mangling going on, so you don't, I don't even remember what the actual name is of the method that is called, instead of plus. So there's a lot of kind of boilerplate code that's going on under the covers.
I assume this is one aspect of dynamic programming, meaning if you guys were looking at a brand new language you'd never seen, someone asks you, is this a dynamic language or not? What are the 5 things you look for to say checklist, and that something like this would just be one of them, right? This isn't what you see here, isn't like what defines a dynamic programming language. It's just one aspect of it. Is that correct?
You're
I'm looking.
Yeah, you're puzzling me with these questions. But if you give me a language and I want to see if it's like it has static typing or dynamic typing, I would look at things like like we show here, like in the main that you see there, where I look whether you're required to write the types of your variables or not, and whether I can call any method on an object even if I don't know the static type of the object.
For example, you could name a few different programming languages that you know of that have some dynamic programming aspects and comment on a few, right? It's not just Visual Basic here that has these kind of features, even though some of them in VB might be unique.
Yes, but as I said in the beginning, right, it's like you have what's traditionally called the scripting languages, like Python or JavaScript or Perl, where everything is laid bound. So you declare a variable, or you don't even have to declare it sometimes. But the compiler has no notion of a static type, so it kind of everything is done at runtime. Then you have the statically typed languages like C++ or C#, where the compiler has a very strong notion of static type, so it will refuse to run the program if the static types are not correct.
Would you generally say that one of the big benefits is usually less code, less declaration in here? When you have this ability in dynamic programming, it looks to me like you'd have to declare things, more assumptions are made on the fly. Is that right?
Yeah, I mean, I think there are two advantages. I mean, I think the more dynamically typed, I mean, I was using, in the example I was typing, for example, I just left off initially the types, function add 0102, that's it. I didn't state any types. And so it is faster, you can move more quickly because you don't have to always state the types, worry about whether all the types are compatible, that sort of thing. There are downsides of that, of course, which is that, you sacrifice compile time checking of errors, those sorts of things. I mean, if I had tried to add two things that didn't have a plus operator, then you wouldn't find that out at compile time. You'd find that out the first time you dealt with that kind of data. But the other advantage, I mean, besides just being able to write code more quickly and more concisely, is that also in situations where you're dealing with data that's coming from outside your program, that's really where it can make a really big difference. I mean, one of the examples of a dynamic programming language, or dynamic style programming language that is sort of, on our floor here is, the FoxPro language. And part of the reason that FoxPro is so dynamically typed is because you're dealing with, database tables where the data types can be in constant flux. And when you change your column name, you don't want to have to go rewrite all your code because, you changed it from integer to float. As long as it's a numeric type and it fits with all the operations you wrote, great.
So that's very similar to the function here in some sense, the print name, right? We only assume that the argument has a name property, but we don't care if it has other properties as well. So as long as you hand me, anything that has a name, I can kind of, access it and do stuff with it.
So it sounds like data-centric programming can really benefit when you're dealing with a database application or going against some data, whether it's SQL Server or something else. You could really take advantage of a lot of these things then, not
Yes.
just a pure algorithm.
Right. I mean, if you look at where a lot of the dynamic languages are scripting languages for exactly that reason, is they not just database driven, but also any place where you're working with data that comes from somewhere else and might be in a format you're not familiar with. So like on the web, obviously, you're going to get some XML document or some HTML fragment or just something the user typed in, and you want to be able to handle whatever comes in. You tend to want to have a more dynamic programming experience.
So you can also kind of explain it like this. Suppose, I want to make this DVD and person strongly typed or statically typed, which means that we have to kind of invent, say, an interface, like, has name or something. But now we are a problem because suppose that you guys kind of, create these types. Now we have to kind of, decide between the three of us that we have this interface, has name, which is kind of unrealistic in a distributed environment because we are defining these types, independently. So then when you two guys each give me a type, I don't know, we cannot decide on an interface beforehand. But I do know that there's a name property, so I want to be able to call that without having to kind of, pin myself down on a type that I can give to that argument such that it's strongly typed.
Right.
So it allows for much more flexible programming because sometimes you just cannot define a type statically.
I think probably the way I'd summarize it is sort of any situation where there's a loose coupling between your component and another component is where dynamic programming really comes in handy, because it helps you become more resilient then to that changes in the contract between you and the other component. So,
yeah.
Now, what we've been seeing is VB Whidbey, that's VB 2005.
right.
You have thought, because you've added things since VB 2003,
Mm-hmm.
the Everett code name, and do you have ideas of things beyond what we've seen here?
Yeah. So do you want to show the kind of dynamic interfaces where we can make it even more dynamic? Because, for example, one thing is here, if you look at this code here,
Where?
here, the print name, for example, there we already know, in some sense, at compile time, that we want to get the name property. But again, that is a decision we make when we write the program. But imagine that, I give you a value that has some extra metadata that tells me what is the interesting field I want to discover. Okay, so for example, Paul, there's...
Right. Well, a better way
Yeah.
to put it is if you look at, if we clean this up a little bit.
Yes.
Say for print name, first I wanted to do something with the name. So dim s is string, and I say obj.name. So I actually want to type I want to say this is a string. And if you look, actually, I guess it's, maybe this isn't the best example. Huh. Because this is going to give me, it's just going to say it's not like that.
Yeah.
All right, well, I think you were going with an example before I interrupted you. What were you?
Yeah. So imagine that we don't know the name at compile time. So, but you give me this object, and it will have one thing. That, let's put an extra field in there,
Okay.
and call that well, let's just say interesting property as string. Okay, and then let's change name to foo there. Okay, and let's do the same here. Let's call the property name there bar, just for because we're doing an abstract example here. And then let's also put an interesting property as string there. Yep. Okay, so now the thing is, there might be many properties in this class, but when you send me an instance of this thing, the interesting property will tell you which of the fields you need to read. But I don't know now statically anymore what it is, right? So what you can do now with the dynamic identifiers, I can do, and then object dot, does it hang?
It's considering.
Yeah, yep, you have to, there's, this is just, you have to kind of type that, there's an IntelliSense bug there. Yep, so now you can kind of continue this.
Oh, it's gonna, alright.
Are we looking at a unique build of Visual Studio?
Yes, yes, you were asking, you asked for stuff that we're going to add. Well, this is what you get when we're using cutting edge features, so.
It could be the fact that we're late finding interesting property.
Yes. No, this should work. Yep. I think it's complaining about the ad down there.
Oh, yes.
So,
Alright.
okay, so now we should kind of, we should create a person and a DVD, right?
Alright, so that's going to run. Okay, I just want
Yep.
to make sure that's... Alright.
Okay, so while it's typing, I can explain what's going on here. So what we're saying here is get the interesting property of the object, which gives me the name, and then I'm indexing, I'm calling that, the field or whatever that's defined an interesting property on the object. So I have kind of this extra level of indirection. So here for interesting property, what was that, bar? Or? Yep.
Once we crash the compiler, certain things are not going to work, but let's see.
Is everything we're looking at related to DB 2005, or is this something new? Or are you leading up to something new?
Well, this is like, this is beyond 2005.
Okay, just wanted to be clear.
Yeah. So is this giving? Are you
Oh,
sure
I
that it's?
forgot to. I know what it is. Huh. It always works better if you.
Oh, we have to print name. Okay, yes, sure.
All right.
Yep.
Oh, there, here we go.
Oh,
Alright,
look at this.
So what happened here? I'll sort of. No, I can. If you want to focus on the screen, what happened here is, what this does, this kind of dot parentheses syntax does is, and maybe this is. Were you explaining this while I was typing?
Yes,
So,
but you can explain again because
So-
this is like really kind of
Right. So what happens is, at runtime, this property is evaluated, and it returns down here the value you gave it bar, and then that name is then fed back into the late binder and used as the qualifier for object. So this becomes object.bar. So you can dynamically choose which method which property or field or method you want to call, based on some choice you make at runtime.
So this is kind of now you can do extremely late binding. So. And I don't know many languages that allow to do this kind of late binding, because often you have to know the member that you're calling statically. But here, you can even delay picking the member that you want to call until runtime, but still have a kind of nice syntactic form to do that. So it's still very convenient and easy to write.
Do you still see this unique to Visual Basic?
Yes, yes. As I said, I don't know any other language that has this possibility.
And I think one of the other things we've been talking about is sort of taking it in a different direction as well. One of the names that is sort of given to late binding is it's also called duck typing occasionally, and it's sort of called duck typing because it's you say, as we did in here before, object.name, and it's like as long as it looks like a duck and it quacks like a duck, it is a duck. So as long as the object you pass has a name property or a name field, then everything works fine.
It does sound to me, if someone wanted to learn more about dynamic programming aspects of VB, one thing to do is learn a little more about how the compiler works,
Right.
and not just the VB language reference guide. You say?
Well, the nice thing about all this late binding is that you don't really need to know because it's
I don't mean
all
the behavior,
very,
not the architecture, but just the behavior.
Well,
like what's going to happen when the compiler makes this assumption for me.
well, but the thing is, I would warn against it, or warn. I don't think it's that sounds too complicated. But the nice thing is what we're trying to do is that the behavior when you're doing late binding is as consistent as possible as the behavior that you get when it's early bound. And that's because, as we said before, at runtime we're repeating a lot of the rules that otherwise would happen statically. So in some sense it's kind of completely seamless. So if you have something that has dynamic type DVD and you're doing late binding over it, it will behave the same as when you would do early binding over it. So you should not have to learn new things to use late binding because we're trying to make it as consistent as we can. There are a couple of places where you can see whether you do late or early binding, but in general, it's completely seamless. So.
What else do we want to talk
Oh, well, there's
about?
one final thing I was sort of getting at it when I was starting to talk about it when we were talking about duck typing,
Yes.
and I can't actually show it because we don't have a working prototype of it right now. But it's this idea, if we can use
Yes.
the whiteboard
Yep.
for a second. So it's like what I was saying before is that, like, today, demo is object. You can say console.writeLine, o.name. Now what happens here is you as the programmer know, okay, whatever object I get here, get whatever. Whatever object I'm going to get here, I know that it at least is going to have a name object. And in fact, in this case, I probably know that this is going to be of type string. I expect that this gets back to the idea of duck typing, right? That any object is going to have this property name and it's going to be a type string. But the problem is, of course, although you know it, the compiler doesn't know that. And so what happens is, like when you say O dot here, you get no intelligence at all because the compiler knows nothing about what you expect to see after this. And so what we've been talking about is sort of an idea of sort of a dynamic interface. So here, let's put it above. So just this is made up syntax for the moment.
Yep. And so what I said before, right? We cannot define an interface beforehand because then you would every party involved would have to know that interface. So with these dynamic interfaces, you, the person that makes the assumption about the type, can define that interface. So you do that locally, so it's still kind of loosely coupled.
All right, so what I have here now is a dynamic interface. And what it means by dynamic is to say, this isn't actually an interface that anyone explicitly implements. Instead, it means that anything that I say, anything I cast to this dynamic interface is going to have a property that's called name, and it's going to be a type string. So now what I can do down here is I can erase this object. I can say demo as has name. Now this is still, as far as the runtime is concerned, this is still object. I can assign any object to this variable O still. So this can return any type you want. But what happens now is when I hit the dot here, the compiler says, oh, okay, you told me that this thing is going to have a property called name and it's going to be of type string. So I'm going to do the same late binding I did before, but I'm going to, for IntelliSense purposes and for other typing purposes, assume that there is this property name and that it's of type string.
So the nice thing is now also that the return type of o.name is string.
Right,
So
right.
now suddenly, you're back in the statically typed world where, now you have IntelliSense and more efficient access. So this kind of, dynamic interfaces allow you to kind of even more smoothly move between static and dynamic typing.
And this is
Yeah.
incredibly useful in the cases where you get things like XML documents or database rows back, where the shape may change over time, but you want to make sort of a minimal set of assumptions about that shape, and then the object is free to change on its own, and your code is going to continue to run.
So it sounds like there's a lot of new dynamic features in VB 2005, but you're thinking really hard about adding a lot of cool new features in this area for after with
Yep.
Vick.
Definitely.
Yep.
Definitely.
Yep.
So anything else that you want to conclude on? What areas of Visual Basic 2005 should developers spend some time to learn if they're excited about what they saw but want to make sure that they're going down the right path and so forth?
Well, yeah, I don't know. It's
It's a hard question
yeah.
because the interesting thing is that so many of these features that we're talking about, well, not necessarily the new ones, but the features we were talking about earlier in Whidbey, the interesting thing is that most of them you don't see. I mean, for late binding, we did an incredible amount of work to make all those things like generics and things work with it. And from the user's perspective, you just make the call and it works. It just works. And there's no new features to learn. There's nothing fancy. You learn the other new features of the language.
Some of the best aspects or benefits of it are when you don't even know you're benefiting from
Exactly.
it.
Exactly. So this is what when you asked before, do I now need to study the language manual or compiler? No. That's it. It's like all kind of happens kind of very smoothly. It's like completely, we try to make the seams go away. And like with these things, we're trying to make the seams even go away more.
So
Right,
instead of
so-
saying you're doing dynamic programming, you're really saying we're categorizing the benefits of the language and the compiler by saying it's dynamic.
Well, what we're saying is really, it's like, it's you can use static typing where possible and dynamic typing where necessary, and you can switch between them, really, really easily. So you're not stuck in one world or stuck in the other world. But, we give you the choice where to be, and you can dial between these two worlds, and it's kind of smoothless,
And-
smoothly,
And
or
for .NET,
effortlessly.
for .NET programming, VB's trying to be very aggressively innovative in this area, correct?
Extremely innovative, yes.
Anything else, Paul?
No, I think that just about covers it. I mean, I would definitely encourage people to watch we're going to be making more of these because this is not the only thing we're working on sort of past Whidbey, but this is definitely one of the exciting areas of it. So.
Okay, thanks guys.
Okay,
Thanks.
you're welcome.
Bye.